Hi everyone, this is the setup video for the lab on magnetic fields and forces. So here I've placed out on my desk all the materials that you'll be using. So you don't really need to use the multimeter this lab, but it might be helpful just when to use when making your coil of wire. Your multimeter might be black, it might be orange or yellowish like this one. You will need the iLab device. You will need a breadboard. There's a battery pack here that has two AA batteries in it. The magnet wire, which is here, and it should be like a red wire, probably like that, unless you got one that's like a green wire. It might be green. This is the sandpaper. Here you have what we call these banana plug cables. These plugs, I don't know why they don't really look like a banana, but and then on two ends they have these alligator clips. And then if you want, which I'm going to show you in this video, this is the conductive tape. So it's just like this little copperish color tape, and it's got a paper backing on it, and you just peel it off and rip it off as you need it. These are what we call jumper cables. Okay, and these are nice because they really plug in nice and easily into the breadboard. And then if you want, you can use the electrical tape. There's several different colors, so this one's green, but you might have gotten whatever color. And this, if you're going to use this, you probably should use scissors. It's really hard to tear the electrical tape. So the first thing we'll do here is we'll make the coil that you see in figure 2 of the document. So if you have a brand new coil, then it's got a little bit of plastic on there, so you just have to peel this plastic off. And if you're a recycle freak like me, you could just bunch this up and you could stick it in with like your plastic grocery bags from the store. And where they have store return plastic bags, you can throw it in there. And then you just want to kind of unwind the end piece of the wire here. And then what you do is, to make the coil, what I am going to do here is I'm going to place the iLab and the multimeter together just to have something to wrap it around, so we get a nice good sized coil. Alright, and make sure you just leave a few inches of lead wire there, and wrap it around as many times as you want. Just make sure you count the number of times that you wrap the coil. And the first couple is a little bit tricky, and if you want, you can take a piece of tape, which sometimes helps. I'm just going to use regular Scotch tape, and you can tape that first lead down. That way it'll help you get this wire going without having to fiddle with it too much. So just wrap that around, whatever you want to do, 5 turns, 20 turns. You got plenty of wire here. Okay, and then once you got it all wrapped up there, you could simply just break it with your hands because it's really thin, or if you want, you can use scissors. And then just try to slip your coil off. And at this point, you'll have to undo the tape that you put down. And just try to keep that coil together. And here we have a coil. It's kind of rectangular shape just by the nature of it. So if you want, what I'm going to do is I'm going to turn it into a circle. As you'll notice in your study, though it doesn't really matter if it's a circle or a square. We'll still get the same results, but we'll just make a nice circle here. And then if you want to try to keep it together, you can kind of put a couple pieces of tape just to kind of hold it together so it's not spiraling out of place. So you can use Scotch tape or whatever tape you have available, or you can use the electrical tape. So I'll use the electrical tape here. And this just is going to help keep things a little bit easier to work with, that's all. Okay, so now we have a pretty decent coil of wire here, and then the ends, we're just going to need to sand those ends off. So just got to be careful because this is so thin that it's easy to break. Like you saw, you can break it with your hand. And so what you can do, if you have a surface that you don't mind scratching, like I put a big piece of paper down here, you can just hold down your wire and just push at it like that, and you'll start to notice that that red color or green color, if you have the green wire, will start turning copper. A little bit harder to see here, but the picture in the document should look a little bit better. And you want to make sure you get all sides of it. So also what you can do, instead of just placing it on the table like that, you could kind of take the sandpaper and just squeeze it a bit. But just remember, like I said, if you squeeze too hard, you'll rip it off. You'll have to start over again. Okay, and then just check it, make sure it's nice and copper on all sides, and that way you'll get a nice good connection. And just maybe like an inch. You don't have to do much more than that. Even if you have half an inch, that should be fine. And so now we should be all ready to go and start hooking things up. So we'll take the breadboard here. So the kind of the way a breadboard works is that basically you see all these ports that are next to the blue line, and on top of that blue line there's a blue minus sign. All those ports are connected, all of them along there. Same thing with under the red plus sign and along the red line, all those ports are connected. Okay, and then on this side, right next to there, you have the letters here. So there's A through E on this side, F through J on this side, and so all of those are connected. And you can see actually there's some numbers there, like a number 1 there. So all the ones are connected like that. Then there's a bridge across, and it's basically the same thing on the other side. Okay, so what we're going to do is we're going to take the AA battery pack, and it's got 2 leads there, red and black, and you'll see that they are they're stripped off there at the end so you can plug them in. And so I'm going to plug in the red to the red. It doesn't really matter if you get it backwards or not. Just want to make sure get it in there or not. So you could put this in the minus and it would still work if you had them backwards. So for this lab it's not going to be too important, and I'll put the black one in the minus, and I'm just putting it in the first one here. It doesn't really matter which port you put it in. Like I said, they're all connected there. And I'll place that down, just make sure they're all in there good. And then your battery pack has an on-off switch, so we'll just keep that off for now. And then you will take your multimeter, and what we'll do here is you have your banana plug. So you have whatever colors you have. Mine are just green and blue. Doesn't matter. They're both the same. And I'm going to take one of them, and I'm going to plug one of them into the bottom port that says COM on it, and then the other one I'm going to plug it into the top port. All right. And next to that you see there's a 10A max there, and so you'll just leave that middle one empty. And then we'll take one of the ends, doesn't matter which one, with the banana plug, and we'll clip it onto the jumper wire, the end of the jumper wire, and then we'll place that into the breadboard. And it doesn't matter whether you plug it into the plus or the minus. You're just going to have one in the plus and one in the minus, so I'm just going to choose to put this one in the plus. So any of those ports there along the red, they're all connected. All right, and then for your coil that you made, you'll take the other jumper wire and you'll connect it to one end that you sanded off there. So if you're having trouble, if it's not holding on tight, you could just bend over the tip of your wire that you sanded off, Just make sure that you're connecting it to the copper. It's touching the copper, right? Because what we did was sand off. We sanded off this painted on enamel that's painted on. That's what is actually the insulator on this magnet wire. And then you could, we left the negative port open on the breadboard. You could plug this straight in there, but you'll find it's so thin, it's hard to get in there. So you could fold it in half, plug it in there. But what I'm going to do is I'm going to take a piece of the conductive tape, just tear it off really easy, pull the back off, okay, and then I'll take the other jumper wire and I'm just going to tape it right on there. So we'll tape that sanded off end right onto there, just so it makes a good connection. All right, you just want the copper end that you sanded touching that, and then now you'll be able to plug that end of the coil in nice and easily into the negative port. And then finally, we'll take the IOLab device, we'll get that in place, and what we're going to use the IOLab device for is to read the magnetic field that's passing through the coil. And so the magnetic field is indicated by this M up here, and it's actually slightly below the top here. It's not on the top, but we're gonna center the coil so it's directly over that M, okay? And we want to make sure it's nice and flat against that. We don't want it bumping up at all too much. It can bump down slightly since the magnetometer, the magnetic field sensor, is slightly underneath there. And then what you can do is, just to keep that in place so you don't have to keep fiddling with that, you can just tape that down with whatever kind of tape you have, just so that you have the center of the coil is directly over the magnetic field sensor. All right, because as you'll learn, the magnetic field changes depending where it is in the coil, and so the highest will be right in the middle of the coil. So that's what we want to read for this lab. And then in your multimeter, what you're going to do is, whether you have the yellow one or the black one, they're the same. You're going to turn that to the right over to the 10 amp setting. So that 10 amp setting is kind of like right above where you placed that one wire. All right, just says 10, just has a 10 over there. That's it. So pointing on there, and then you'll be able to read the current with that. And so so this is sort of like a short circuit in a way, so you want to be careful here that you don't have the battery on too long, because these wires will get hot. All right, so you don't want to touch. I mean, they're not going to be too hot, but if you keep it on for too long, you will start causing some danger. So so just try to keep this on for less than a minute at a time, and you'll see once I turn the battery on, we start getting a current there. And so we'll see the negative sign just indicating to us that how we plugged it in. So if we wanted to get rid of that negative sign, we could flip the direction here. We could flip the one that we plugged into the plus and one that we plugged into the minus, right? Because negative, remember, negative just tells us direction. And so if we try that now we see the same number but positive. And then the final part of your lab, you're going to kind of look at everything you did here to try to determine mu naught, and then you're going to try to kind of reverse engineer what you did with the coil that we've provided for you. So it's a coil, it's just wrapped in electrical tape, and it's got a couple of lead ends. They may or may not be sanded depending on how much of a rush we were in to send the kit out, so you may have to sand those ends. But this is a lot thicker wire, so it will go into the breadboard nice and easily. You won't have to worry about taping it to one of the jumper wires. If you want to, you can, but it's not really going to help much, I don't think. And so you're going to reverse engineer what you did here and try to determine how many turns are in this coil. All right, so that's it for this lab. and we'll see you next time.